my presentation. The presentation is about how to install the Woodstock LP. I don't know whether all of you have heard about my small development. Last year I made a replacement circuit for the Woodstock calculators if they are damaged. And some years ago I had already a replacement by the arithmetic chip. You have it inside, thank you. And but there were a few calculators which could not be repaired by this ACT replacement. And therefore I thought about another circuit which could replace every damage and repair the calculator. The calculator mainly consists of the arithmetic chip, the RAM and ROM, and the display drivers. And if the display driver chips were defective, I had no chance to repair it with this ACT. This was the idea to develop the Woodstock LP. And LP stands for low power, because after the development and removing all the original chips, I saw I didn't use the power supply. The power supply, it's a switching power supply inside the HP25, was not longer needed. And this was the main power consumption. It was so ineffective, and you can drive the new circuit just with the battery. And if this chip, the PIC microprocessor, goes into sleep mode, it consumes only microamps, and therefore you can leave the calculator on your table, and after 1 minute it switches off and doesn't lose any calculation results. That is the reason for low power. But today I will show you performance with my soldering iron to build the LP circuit, how you can do it by yourself, repairing your calculator. And you get, if you want this circuit from me, but you have to install it in your calculator by yourself. And that's what I'm doing here on the table. It was planned to show this with the camera on the beamer screen, but the installation was not possible. So I will do it here, and you can show if you like. You can go and see what I'm doing, but I will describe what I'm doing. That's the only thing I can do. So this presentation has two parts. The first part is to install the LP circuit in one calculator. This one. This is a damaged HP21, and I hope I can install it here. And then I will show you a new feature of this LP circuit. I don't know if anybody has already one from me. Got? Okay. And you have a version which is fully functional, of course, but I developed a new version which has communication features with the PC. And that I want to show you after the installation. And now it's very difficult for me because I forgot to bring my real LP calculator with me, which I normally wanted to show you. And now I have to repair this one. There's no way, otherwise I cannot show you the functions. So please give a thumbs up that I will get it running. And how to install? I have four items of this small presentation for you. Perhaps you can, I could not bring 20 or 30 of them. You can have a look. It's just a small description of how to install it.
While you're setting up, can you get the main camera
So we start with open the calculator. The Woodstock calculators have the Woodstock calculators can be opened very easily by removing the two screws on the top side of the calculator. I already did that, and and it should be easy to take the pieces apart. The case, and here we have an original HP21. I will go a little bit in front because we don't have the camera. What you see here is the display, the ACT arithmetic chip, and this is the power supply, switching power supply. And below the display, which you can remove just by getting it pushed, just by taking it away, you see two display driver chips. What do we have to do? We have to remove these three chips, and then we can insert a new circuit. And now I cheated because I have already removed these chips, and I have to just to unsolder one pin and get them out. Otherwise, I needed half an hour more. So let's try. I start with the anode driver chip, and miraculously it's already removed. So normally you need 10 minutes or 15 minutes for one chip because there are so many pins. Now the cathode driver chip is already removed, and the next one, the arithmetic chip, normally does not need to be removed, but because it's connected to the keyboard, also together with the LP circuit, it consumes some milliamps, and this is not what we want. We want low power. So I remove also this ICT, and there is it. Next is I have to remove the solder from this pin, which I just removed. And what you need for removing the solder is this copper braid, which removes the solder from which is left and some pins. I'm sorry for not having the camera for you, but if you can imagine what I'm doing here.
Do you prefer the solder wick to one of those solder sucker tools?
Yes.
Equally good, or?
Yes, you really need it to remove the remainder of the solder. After you use some vacuum or desoldering tool like that, there is still some solder left, and you remove this remainder from the pins. So I have removed, and when the braid is full with tin, I remove this tip, and now I have a new part for the next. And because my eyes have a built-in microscope, if I remove my glasses, sometimes I will do that. So don't. If you are short-sighted, you have a built-in microscope. It's not very high magnification, but not bad. So now the second. And the third pin should be okay. So we can see I removed these two display driver chips. And the ACT chip also. So what's next? The next step for the replacement is to insert the new circuit. I have to look. Don't do that
Do you
every day.
remember? You invented the procedure and you don't remember it?
Sorry?
You invented it, now you don't remember.
Yes, yes. You should do that, what I'm doing here. Okay. The new circuit is delivered like this in a package together with some extra material, and now it's not static sensitive. If it is, you get a new one. The circuit fits below the display, and because we need a connector to the keyboard, there is a copper, there's a wire tree which must be soldered on the other side of the calculator where the keyboard connector is. So our task is to insert this and then to solder also the keyboards. The first question is, does it fit? And there is a real problem. Some of these calculators, there were 100,000 were made. Some of them have different distance of the two display chips. 1 or half a millimeter nearer, and then this will not fit. Fortunately, I made the right decision and made this for 95% of the calculators it will fit. But I had two of them which the pins are not the same. But I have a solution also for these calculators. You have to remove one of these sockets and make wires instead. So this is also possible to repair. In this case, I know it fits because it was already there, and I hope I can push it inside these pins. Yes. This part is done. This part is done. And I think there is a little bit too much solder on this pin. Therefore, you need the braid. You have to remove the solder completely. I got it. Sorry?
Can you ask questions while you are working?
Yes, please.
So this low power circuit is the only thing you need to replace. You don't need to replace the X as well.
You need to replace the
ACT as well.
The ACT and the two display drivers. This is the only thing you need
Okay, so
to
the
replace.
one was just the display driver.
The display drivers because they were replaced by this circuit, and the ACT because it will consume some milliamps from the battery, which we don't like.
Okay, you have to remove the ACT. So
Yes,
not put in a new one.
No, you don't need a
Okay,
new
because
one.
everything is on the display.
This is a replacement for the complete circuit.
Okay.
You can even replace the power supply.
Okay,
So you see the progress of 40 years.
Yeah, but it's impressive. Yeah.
Yes. Okay.
Yes, it comes with a full plating.
Now
PC.
I got the circuit in the pins, and I will solder them. The next step is to solder some copper wires, which are necessary to get all the connections. The pins which we inserted here are the only display pins, and we need some power supply extra wires, only 3, and then it will hopefully come up.
So you're replacing also the power supply?
Yes, because the power supply is not needed, and I connect the batteries directly to the circuit.
Okay, do you need to break the PCB
Yes.
line on PCB in order to cut the line with the power supply?
I cut the line to the power supply, exactly.
By removing some copper on the PCB.
Yes, and I cheated again because this is done already on this circuit.
No, it's just that, because I just heard you that saying that the power supply is not needed, at some point you need to.
Yes, it's mandatory to remove the connection to the power supply, because otherwise it will consume power, and that's what we don't want. So I have to solder all these pins. These are altogether 20 pins, no, 22, and I will do that very carefully, because this is my only chance that it is working in 20 minutes. I got already this.
You feel no pressure now, right?
Okay. And now the next step is the keyboard. The keyboard is a keyboard matrix with 5 by 7 lines and columns. And this is the reason why the HP35 is the number 35, because it has 35 keys, and this is 5 by 7. So these 5 columns, that is the 5 lines which I have here. And I have to solder it on the 5 pins of the keyboard, which is on the bottom of the circuit. I will do that now.
So this is a socket.
Yes, because if I use the socket, then I can remove the circuit. I did not solder the circuit here. Okay, I did solder the sockets also of the circuit. So after soldering, you can remove that completely. But normally, you won't remove it. So let's have a look. This is pin 4 to 9. I have to solder 4 to 9. 4, 5, 6, 7, 8, 9. Because this is a real-time live event, there are some pauses and it needs a minute of work. You can ask any question if you like in the meantime.
The functions are the same as in the previous upgrade for the ACT?
Again,
The functions are the same as in the previous ACT, or did you do that in
that is a very good question. The functions are including all the functions of the previous ACT, but there are much more functions. I have written a manual which can be downloaded from my website, and there are all the functions, but I will tell the main functions. The main new functions is this circuit contains a real-time clock which is running also in sleep mode when the calculator is switched off. So you have the time, you have the date, you have the weekday of the year, and there's also an alarm time. And what you see here as a part of the LP circuit is a buzzer, beeper, and this will beep if the alarm time is matching. That is one of the features, the real-time clock. And the main feature is, of course, a flash memory of 512 kilobytes. This is, for a calculator, if this is overkill. The HP25 had 2 kilobytes of ROM code and 112 bytes of RAM. And we can use this flash chip also as RAM. So you can store 10,000 of programs, of HP25 programs, if you want. I didn't implement 10,000, I implemented 100. That is enough. And because this memory is really big for this calculator, this circuit is able to emulate not only the HP25 but all the Woodstock calculators. You can switch between them simultaneously. Yes, it's all you have not to change any circuit. You just change with the keyboard the calculator, and not only the 25 and Woodstock models, also the 30, the Spice models, and the classics. The HP35 is also in this circuit, and the 67. Did I forget? Yes, there is also that the classics, the Woodstock, the Spice, and the 67. That's inside.
To watch.
The HP01 is it could have been inside, but the pick was too small. I could not insert enough.
What about the GPS?
Yes, it's there. It's there. You have to connect 2 extra wires with the circuit, and to install the GPS circuit here in front at the place where the ACT were, and I delivered 5 or 6 GPS low power models already.
So it's a different kit. When you buy the low power and the GPS separately, and then you
you buy the LP with GPS in one package, and you have to assemble it. And in the manual is
I tested it already.
you have the GPS version?
No, just quick fall.
Ah, yeah.
Here's the GPS.
Yeah. Yes, it works, of course. I don't have it here, but it works. Now I have to add the wires for the power supply. I hope I will do that fast enough. And I will answer questions during soldering.
Bruce just made a suggestion to me while Hans was doing his presentation to implement the stack overflow.
It is no problem. You can add a red LED, and I have to change the software a little bit. It would be no big problem.
You could just put the LED where the hole would be, so you drill a hole through the case and then it lines up with the new circuit.
and that's become a red version of the HP25.
Or a Morse code decoder.
And I connect the battery now to the circuit, and if you remove all parts of the board, please leave the big resistor and this diode. These are the only parts we need, because then you can use the original charger for charging the batteries. And this calculator is not possible to switch off. It has no switch off switch. The switch doesn't work. So, or I say it differently, if you switch off with the switch, then you see the text off in the display for 1 second. And then it vanishes. So in reality, there is no switch off. It's always connected to the battery, and you can charge it. That's what the original Woodstock never can do.
It's so low power, you never need to charge the battery. It lasts longer than the battery.
So how low power is it, Bernard?
Yes, that is a good question. With 2 answers. First, if the calculator is switched on, what is the low power? The original 25 consumes between 110 to 180 milliamps when switched on. Depending on you write only the number 1 or all 8s, this is 180 milliamps. And this calculator uses 5 to 20 maximum milliamp when switched on. So it's about 10, a 10 factor of 10. And when switched off, it consumes 100 microamps. 100 microamps by the battery capacity of 2000 milliamp hours is several years. So the discharging of the battery is more than what the power consumption is. I have one for myself, one low power circuit. Usually I charge every month, every 2 or 3 months for 1 or 2 hours. And then you can calculate again. My next wire has to be connected. I have to look how it is done. Okay.
And is there some kind of automatic time correction?
Time collection?
Correction of the time?
Yes.
HP 41 or so?
Yes, if you have the GPS module inserted, then you have to press only one button if you are in GPS mode, and the GPS time will be loaded into the real-time clock. So this is very precise, and but this real-time clock is better than the normal ones. It has a accuracy of plus minus 3 parts per million instead of the normal 20 parts per million of normal real-time clock chips. So this is about 1.5 minutes per year if you don't correct the time. That is according to data sheet. I didn't measure it exactly.
So you use a crystal for...
The crystal is integrated in the real-time clock.
Okay.
And it is a special a special temperature compensated crystal. In what really happens is that this chip checks every 4 minutes the temperature, and according to this measurement changes the frequency of the clock. And therefore they have 3 parts per million. And this consumes power. You can choose between every 4 minutes or every 1 minute, but this consumes more power, though I decided to take the 4-minute cycle. Perhaps you know that I last time when I was here in Allschwil, I presented the HP01 replacement chip, and there's the same real-time clock in this, and this is also the idea of the low power was born with the HP01 circuit. So what have I done? I have made 2 wires, and it should be done. I'm not sure what happens if I switch on. It should be done if I am right here. And please press thumbs up. Close the... Of course, here's an infrared diode for infrared printing in this case, and I could also add these wires for infrared printing. I need... but I don't have the time. How? No. Okay, it's inside. I don't have the screws. Let's insert the batteries. And nothing happens. What is the reason?
It would be a proper demo if there's something like that.
Oh, well, nothing happens because the display is laying on the table. So I have a second chance. So, second chance. And battery inserted. HP25 low power is working. Okay. Now I have to close the screws because the battery needs a good contact. And I have the screws in one of my other calculators. And then I will show you the calculator. You can have it in your hand to make some functions. What's the time? I'm still in time?
Yes.
Okay. But
You
the
gained
same.
time.
I-
Because you became
I cheated.
Yeah. You began too late. No, it's good.
Okay. Okay, there is a screw. Okay. So, what we see is HP25 LP, and the keyboard is also working. Is it working?
A question. I normally assume that the most power you use for the driving of the 7-segment display, how you save there the current. Normally it's LED, and normally LED needs about 10 milliamps or 5 milliamps for driving one segment. And so when you have a 7-segment drive and so on, how you do save there the energy when you're driving an LED. The problem of the old calculators was the LED driving and not the current of the CPU, I
Yes,
think.
the LED driving was, the difference was between 110 and 180 milliamps. So they depended on the display, it was 0 or 10 or up to 60 milliamps. And I think my 20 milliamps is because I have a slightly slower voltage, so the display is not as bright as before. But I have no influence because the battery voltage is now driving the LED, and this is 2.7 volt, and this is not really the 4 volts. You can drive it with up to 3 or 4 volts, and therefore I only need 20 milliamps when all segments are lighting. Perhaps it's not 20 milliamps per segment. That is too much. This is about 1 milliamp per segment, I think. So the reason why it was not working the key was because I have a 21 board used instead of a 25 board. And the 21 board has different keyboard lines arranged. They are rotated. The columns from 1 to 5 are not 1, 2, 3, 4, 5, but 2, 3, 4, 5, 1. And I have a trick here. If I press the button while inserting the battery, then I can correct that by software. I hope this will work. Wait a moment. Reset. No, it does not work because I have the newest software, and so I have to rotate the wires until it works. I'm sorry. That is the newest software. I had to remove this feature because there was no space for anything. So what I do, and this is done in 1 minute, is to rotate the wires for the 21 board. You see, my preparations are not perfect, but who
Only a Dutch is funny.
Yeah, first time in this. So he could not stay very dinner or something. But I still, it's nice to speak with him. And we agree on multiple plans and try stuff.
Il est déjà intégré hein, dans la...
60 something.
Non, mais c'est vraiment
Yeah, 55 younger. Not by much. And it's about around 1760, but I don't know. I haven't asked him what it is. It's in Britain. That's a life design. This is designing, creating processes. Designing cities as a job. So this like is a hobby for him. Really like yeah, for 5 years.
I'm very lucky. It works.
All the works I started to do it.
I will show you. It shows this calculator has a feature which I didn't mention before. The display can now show alphanumeric characters. Each text is possible. This was not possible with the 25 original because the display driver chips allowed only the numbers and 2 or 3 characters. So I can show any text. I'm sorry that we don't have a camera which can show that. And let's show, at least here in this camera. What I want to show you is the hidden feature of the low power circuit. It's not mentioned in the manual. It's just for us here. Don't tell it to anybody. It's the key sequence F, F minus. And then you can, whenever you press this, you get, what is it called? Ein Sprichwort, a quote. No, a quotation. In this case, I have, let's say, what comes in the universe. Let's have it a little bit faster. It may be that primitive life is very common, and intelligent life is fairly rare. Some would say it has yet to occur on Earth.
That's the fortune cookie. The fortune cookie. That's the version of the 21.
Does it also make coffee?
Sorry?
Does it also make coffee?
Not yet.
I know what you are referring to.
It's more
But it was
important to
tea.
make the dishes.
Tea.
More important to the dishes than coffee.
Okay. The features are now there are many features which you can see in the manual. And I think I lost a lot of time. I don't know if I can show you any more. We have installed the low power circuit and it works. And now you have all these calculators and you have alphanumeric text. Perhaps this special features, if you program normally any program, you can dictate 1 store -4 enter 2 plus, and normally you see only numbers if you have 25. And if I add the flag 7, then you see it in plain text plus. and enter is written in plain text, and everything like sign, you see sign and the line number and the code. That is a real improvement.
How should we do it?
Plus PL.
No. Oh. Okay. Thanks. Okay.
I know he wanted to ask how can I show the plus sign on a 7-segment display, and indeed the question is okay, because if I show store plus 0, yes, the arithmetic, the register arithmetic, then I have to use the plus sign. It would be too long to write PLUS, and then I have a special. I show you. This sign is my plus.
Okay.
Plus.
Okay.
Yeah. There's.
Show me. As soon as I know, I can read it.
This is store plus 0, and this is the normal plus. PLUS. So I think that is, the time is over. And no, it's not over. Is it over? It's over. Yes.
You are fast. Very fast.
Ah, yeah, of course. The last thing, if the time is over, F divide, and you see the text sleep. And now it's switched off and consumes no power. Low power. Thank you very much.
Thank you.